Hi folks. In this second half of Module 1, we're going to look at isotopes. We've just learned about all of the subatomic particles, protons, neutrons, electrons, and so now is really a great time to talk about isotopes and nuclear reactions. So, the periodic table has a bunch of useful information on it that we do need to know. Each box on the periodic table will tell you the symbol for the element, the name for the element, the atomic mass for the element, as well as the atomic number. And those pieces of information are going to be important for us as we talk about isotopes. Of course, your periodic table here, you can see that each box contains this information: the atomic number, the atomic mass, the element symbol, and the element name. So, the periodic table lists all the known elements in the universe, and as of now we know of 118 elements. Those elements are listed in order by atomic number, and that's listed above the symbol of each element, in order by atomic number. The periodic table also shows for each element the element symbol. The element symbol is one or two letters. The first letter must always be capitalized. The second letter, if present, always must be lowercase. It is important to follow this convention because if you write capital C lowercase o or capital C capital O, those mean two different things. Capital C lowercase o means cobalt, and capital C capital O means carbon monoxide. So it is important to be consistent with your element symbols and write the symbol exactly as shown on your periodic table. We also are given the element name and we're given the average atomic mass. We're going to be focusing first on this atomic number. We'll give a definition for you. The atomic number is the number of protons in the nucleus of an atom. The protons defines the element. What I mean by that, if an atom has 6 protons, it must be carbon, and if an atom is carbon, it must have 6 protons. If it doesn't have 6 protons, if it has 7 protons, it's not carbon. So that's what I mean by the number of protons defines the element. Atoms are neutral. They have no charge because they have equal numbers of positively charged protons and negatively charged electrons. And if you have equal numbers of those, like if you have a charge of positive 6, we'll just go with carbon. If you have a charge of positive 6 because you've got 6 protons, and negative 6 because you've got 6 electrons, when you add those together, you have an overall charge of 0. Now, you should note that atoms often gain or lose electrons in chemical reactions. That creates an ion. An ion is an atom with a charge. And the reason those ions have a charge is because the positive and negative charges are no longer equal, because the number of electrons has changed. I want to put that out there right now, just so that you don't get too used to the idea that electrons always equals protons. That's only true in a neutral atom. If an atom gains or loses protons, then you actually change what element you have. That can only happen during a nuclear reaction. It cannot happen in a chemical reaction. A nuclear reaction is a reaction that changes the nucleus of an atom. Because protons and neutrons are in the nucleus of an atom, you can only change those features in a nuclear reaction. Here are some atomic number practice problems for you to try using your periodic table and the numbers on your periodic table, and pause the video and then come back and check your answers. Lithium is the third element on the periodic table. Therefore, it has 3 protons. And if we have an atom, the atom has no charge. Therefore, we should have 3 electrons. Aluminum is element number 13 on the periodic table, so it has 13 protons. And if we have an atom without a charge, we must also have 13 electrons. If an atom has 20 protons, you need to look through your periodic table for element number 20, and that is calcium. Get used to writing that capital letter and lowercase letter. If an atom has 14 protons, that is silicon. If an ion has 18 electrons and 17 protons, what element is the ion from? Remember, the element does not care how many electrons you have. What matters is how many protons you have. So we look up that 17, and that tells us that we have chlorine. And if an ion has 12 protons and 10 electrons, what element is the ion from? Again, we don't look at the electrons, we only look at the protons, and 12 protons corresponds to magnesium. All right, mass number. The mass number of an atom is defined as the number of protons plus the number of neutrons. The reason we add protons and neutrons is because, remember, with our subatomic particles, protons have a mass of 1 AMU, neutrons have a mass of 1 AMU, and electrons have virtually no mass. They have so little mass that we just call them, we just say that they have a mass of 0. So electrons don't play into the mass number, only protons and neutrons do, because those are the only 2 subatomic particles that have substantial mass. This is always a whole number. You never see a decimal place next to the mass number. This is not the mass listed on the periodic table. Okay, the mass listed on the periodic table is an average atomic mass. Okay, the mass on the periodic table is atomic mass, and that is an average. Here, we're not averaging anything when we talk about mass number. We're talking about the mass of one specific atom. So, now that we know what a mass number is, we can give a definition for isotopes. Isotopes are atoms of the same element that have different mass numbers. Another way of expressing this is that isotopes have the same number of protons but different numbers of neutrons. So, for example, here I have hydrogen that has a mass of 1. Here I have hydrogen that has a mass of 2. And here I have hydrogen that has a mass of 3. Because here I have 1 proton and 0 neutrons. 1 plus 0 is 1. Here I have 1 proton and 1 neutron. 1 plus 1 is 2. Here I have 1 proton and 2 neutrons. 1 plus 2 is 3. So these are different isotopes of hydrogen. They're all hydrogen, but they all have different mass numbers. And the reason they have different mass numbers is they have different numbers of neutrons. It's important to know that isotopes do not differ in their chemical behavior. Hydrogen, whether it's hydrogen with a mass of 1, 2, or 3, will react with oxygen to make water, H2O. It doesn't matter what version of hydrogen I have. They go through the same chemical reactions. But they do differ in their radioactivity and their nuclear properties. We can specify an isotope by giving its mass number. And that's what I was doing up here. I was giving the mass number here in the top left corner next to the element symbol. So let's look at how we do that and how we specify mass numbers. So there are 2 different ways we can write isotopes. Hyphen notation has three parts to it. You state the element name, then you put in a hyphen, and then you write the mass number. So carbon-12 has 6 protons and 6 neutrons because carbon always has 6 protons, but it must have 6 neutrons here because 12 minus 6 is 6. So that's how we know that carbon-12 has 6 neutrons. Contrast that with carbon-14. This is the carbon that's measured when you do carbon dating to see how old a fossil is. Carbon-14 has 6 protons and 8 neutrons because 14 minus 6 is 8. That's where we got the neutron value from. The nuclear symbol notation has 3 parts to it, and this is the symbol that I was using on the previous page. You write the nuclear symbol, and then you write the element symbol, and then in the top left corner, you write the mass number, and in the bottom left corner, you write the atomic number. So you need the element symbol, the mass number, and the atomic number. This is really providing us the same information as the hyphen notation. The only additional information it's giving us is the atomic number. You can argue that the atomic number isn't really necessary because carbon always has 6 protons, so we don't really have to say it. But it can be helpful to write this notation just because it's easy to see without even using your periodic table that this substance has 6 protons and a mass number of 14, so it must have 8 neutrons. So let's try some isotope practice problems. Based off of the information that you've learned, I want you to try to fill out this table, pause the video, and then come back and check your answers. If we have hydrogen with a mass number of 3 and an atomic number of 1, mass number of 3 and atomic number of 1, that means that hydrogen has 1 proton. The way I would write it in hyphen notation is hydrogen 3. How many electrons do I have? Well, this is a neutral atom, so I'm going to assume that I have the same number of electrons as protons, so I have 1 of those. And the neutrons, I have to do the mass number minus the number of protons. So I'm doing 3 minus 1 is 2 for my number of neutrons. The next example, I was given a nuclear symbol, chlorine 37, so my mass number is 37. My atomic number is 17, so that's my number of protons. My number of electrons, because I have a neutral atom, is going to equal my number of protons, so I'll put 17 there. My neutrons, I'm going to have to do 37 minus 17, so that gives me an answer of 20. And my nuclear symbol is chlorine 37. The next example is iodine 131. I know 131 must be my mass number. And I need to look up iodine on my periodic table to see that the symbol is I. And on my periodic table, I see that the atomic number is 53. So that's the number that I put down below. And I write down that my atomic number is 53. And that's also my number of protons, 53. So notice the atomic number is always the same as the number of protons. The number of electrons, because I have a neutral atom, is the same here. And 131 minus 53 gives me 78 neutrons. This is kind of crazy. I'm not given any information except for electrons and neutrons. But if I'm given the number of electrons and we assume that we have a neutral atom, then I must have 15 protons. So I look that up on my periodic table, and if I have an atomic number of 15, that corresponds to phosphorus. So I know that I have phosphorus, and I need to know what my mass number is here. Well, my mass number is the number of protons plus the number of neutrons. So 15 plus 16 is 31. So that's my mass number that I put up top on the phosphorus. And I'm left with phosphorus 31. On the periodic table, you find the average atomic mass. That's the mass shown on the periodic table. It is a weighted average of all of the naturally occurring atomic masses of isotopes of an element. So it depends on the mass and the abundance, how common a particular isotope is. It's important to realize that atomic mass is not the same as the mass number. However, if you need to know the mass number and you cannot figure it out from the problem, if I haven't told you the number of neutrons, then you can use the atomic mass from the periodic table rounded to the nearest whole number. Round to the nearest whole number. So let's do a couple more practice problems where you need to do that, where you maybe need to round to the nearest whole number if the information is not given to you. So you need to figure that out as well. Pause the video and then come back and check your answers. If I have 35 protons, that means my atomic number is 35. And looking at my periodic table, that corresponds to bromine. Now, I know my number of protons and I'm given a number of neutrons. So I don't have to guess or use the periodic table to figure out my mass number. I know I have 35 plus 46 gives me 81 as my mass number. So I have 81 as my mass number here. And I can write my hyphen notation that I have bromine 81. How many electrons do I have? I'm still have just a neutral atom, so protons is still the same as electrons. Second example, I'm given an atomic number of 35. Well, hey, I just looked that up. That's still bromine, so I don't have to look it up again. I'm not given the number of neutrons, and I'm not given the mass. So the only way I can get any information about the mass is using the periodic table. When I look at the periodic table, then I see a value of 79.904 as the mass, atomic mass. But I want to round this off to the nearest whole number, so I'm going to round it off here, and I'm going to see that I'm going to have a value of 80. So 80 is the value I'm going to use for my mass number. Doing subtraction, I can determine how many neutrons that is. So I know I've got 35 protons because that's the same as my atomic number. But now I'm going to have to do 80 minus 35 to determine how many neutrons I have. And this time I only have 45 neutrons. I have fewer neutrons than I had before. So my nuclear symbol is 80. And my hyphen notation, I'm going to call this bromine 80. And the only thing I'm missing now is the number of electrons, and that is 35 electrons, same as the number of protons. Copper 65. If I'm given copper 65, then I know that my mass number is 65. I do need to look on my periodic table to see that copper has the atomic number of 29. So I know I have 29 protons in my copper. So my nuclear symbol will be capital C lowercase u with a mass of 65 and a atomic number of 29. I have the same number of electrons as I have protons, so I'll write a 29 there. And then the number of neutrons is going to be 65 minus 29, which gives me 36 neutrons. Looking at the next example, hey look, the number of protons is 29. I already know that that's copper. But this time I did not give a mass number or a number of neutrons, so I don't know anything about neutrons or mass numbers. So I'm going to go ahead and use the value from the periodic table, and that is 63.546. 63.546. I'm going to round that to the nearest whole number. I'm going to have to round up to 64. So I'm going to put a 64 up top, and I'm going to call this copper 64. Then I can determine, let's see, we already said that this has 29 protons, so the atomic number is 29. I can calculate the number of neutrons by doing 64 minus 29, and that gives me 35 neutrons. And my number of electrons should be the same as my number of protons in a neutral atom, and that's 29.